In this unit, we are going to work with special right triangles, but what we're actually going to do with those, with the properties, is relate them to proportions and similarity, so working with similar triangles like we did in Unit 5. So we're going to go ahead and work with some of that and talk about why these things are considered special right triangles. So what is it that makes these things special? Why is a 45, 45, 90 special? Well, the reason is because it's half of a square. If I were to take a diagonal line and connect one vertex to the opposite, I get right here two 45, 45, 90 right triangles. So that, and then these are obviously all the same because it's a square. And so again, same thing up here and down here as well. So that's what makes this one a special right triangle, is that the sides being the same, it's isosceles, so that's kind of helpful to know. And then we can apply some special measurements within it. Now with a 30, 60, 90, if we have an equilateral triangle, so 60, 60, 60, and all these sides are the same, well, what happens when we draw in an altitude, so I'll go ahead and put this altitude right here. So remember that thing is an altitude. And that makes a right angle, which cuts this in half also because it's a right triangle, or because it's an equilateral triangle. So then what it does up here is splits this 60-degree angle into two 30-degree angles. And then we have a 30, 60, 90. Okay, so let's go ahead and work with that little foldable that I gave you in class. If you lost it or don't have it or whatever, it is attached to this post as well, so you can just print that out. So starting with a 45, 45, 90. So we have a little bit of things that we need to remember. First of all is the fact that this thing is isosceles. Really important to remember that. And the reason that that's important to remember is because if this and these two legs are congruent, that automatically makes these 45 and 45 because those would be considered your base angles. So the numbers that you have to memorize are 1, 1, and the square root of 2. And basically what we're going to do is relate everything back to this. And so we're going to use proportions. Okay, so I want you to go ahead and write that down. We're going to use proportions. So if you can memorize this right here, using the proportions is going to be really super easy. So I'm only going to do 2 examples with you. So just do those 2 and we'll do the other ones when we're together. Okay, so we're actually going to do examples 1 and then 3. So here's your first example. So here's your triangle. And how do we know that this is isosceles? Well, these 2 are marked as congruent, which automatically makes these the same. So this makes this angle right here 45 degrees, and this angle right here will also be 45 degrees. So here's what we need to do. We need to relate our sides. So this side right here, this x, is going to pair up with the 1 because we want to do proportions. And then we need to take our other side, our 5 times the square root of 2, and we're going to put it over our square root of 2 from the side that it corresponds to. So x over 1 equals 5 times the square root of 2 over the square root of 2. And now normally what we would do is our cross multiplying. And so even just to kind of give you an idea, I did x over 1 that like this, and then 5 times the square root of 2 over the square root of 2. So when we do our cross multiplying, remember that we go up and over and we get rid of our fractions. So we get x times the square root of 2 equals 5 times the square root of 2. In order to get rid of the square root of 2, we divide by the square root of 2, and that makes it a 1. This is also a 1, so we end up getting x equals 5. So there's our x value. Now, since x and y are congruent because of the type of triangle it is, this is also, y is also going to be 5 as well, without really having to put any work into it. All right. So that's your first example. Now example 3, so this one's a little bit more difficult just based on the way it's set up, but we're going to go ahead and do this exactly the same way. Now look, x and y again are marked the same, so that means that this angle here is our 45-degree angle and this angle down here is our other 45-degree angle. And now we need to pair up our sides. So if we, let's say we did y first. So y is going to match up with 1, and then our 2 times the square root of 6 is going to match up with the square root of 2. So if we go ahead and pair up our sides, y over 1 equals 2 times the square root of 6 over the square root of 2. Now remember, you want to keep it consistent, so on top I have this triangle, and on the bottom I've got this triangle. So keep it consistent. So do your cross multiplying. So y times the square root of 2 equals 2 times the square root of 6. Now this time when we divide by the square root of 2, these are going to become a 1, leaving you with y. And this one here, because the 6 and the 2 are both under a square root, you get to do 6 divided by 2, which is 3, and leave that under the square root. So there's your y value, 2 times the square root of 3. And now because of these markings here, x and y are the same, so x is also 2 times the square root of 3. Okay? There we go. All right, so now same type of thing, only with a 30, 60, 90 right triangle. And so in this case, we don't have anything, that it's isosceles, but we are still going to use proportions. So you need to remember that if this is the 60-degree angle and this is the 30, this side will be your 1, this side will be your square root of 3, and this side will be your 2. And it's always going to work that way. So once you have that memorized, again, we're just going to work with similarity and proportions. Okay, so let's just go ahead and jump into 2 examples here. And all we're actually going to do is number 6, and then we are also going to do number 7. All right, so let's go with x first. So x is next to the 30. If this is your 30-degree angle, that makes this your 60-degree angle. So the x is next to your 30-degree angle. So that means that's going to pair up with the square root of 3 because that's next to your 30-degree angle. So x gets paired up with the square root of 3. Now we want to match up sides that already have all the information we need. So 7 times the square root of 3 is next to your 60. That pairs up with your number 1. So 7 times the square root of 3 divided by 1. Okay, so we're just writing our proportion. Cross multiply to get x equals 7 times the square root of 3 times the square root of 3. Well, when you're multiplying these, what you get to do is make this the square root of 9. And we know that the square root of 9 is 3, so our x is 21. Okay, so there's your x. But now we need to repeat this process, only this time we need to go with our y value. So here's your y here, and y matches up with the 2. So we're going to go ahead and put our y over 2. And we're going to set, so we did y over 2 equals, and we're going to come back to this because it's the same number over number. So that way we only have one variable. It's all you want in the equation at a time. So we're going to multiply, do our cross multiplying to get y equals 2 times 7 times the square root of 3. Now this time, see how the 2 and 7 are outside of the square root? Those two are going to get multiplied, which gives you 14 times the square root of 3 as your answer. So there you go. So anytime 2 numbers are underneath, they can get combined, and anytime 2 numbers are outside, they can be combined. All right, and just one more example. So let's go ahead and pair up our sides. Y is next to the 30, so that is going to pair up with the square root of 3, which is next to the 30. And then we're going to go with our 12 times the square root of 3. Now remember, this is your 60-degree angle here. And so that is next to your 60 degree, so that's going to get paired up with the 1, which is next to the 60-degree angle there. So we're going to take y and put it over the square root of 3 and set that equal to 12 times the square root of 3 over 1. Do your cross multiplying to get y equals 12 times the square root of 3 times the square root of 3. Now remember that when you multiply those, that gives you 12 times the square root of 9. Well, the square root of 9 is 3, so you get y equals 12 times 3. And so what that ends up giving you then is 36. So let me replace that with this 3. There we go. And so we get y equals 36. And I'm just going to write that up here just because I'm out of room. So there you go. Y equals 36. All right, and then we need to go ahead and solve for x. So this time we're looking at our x, which is on our hypotenuse, and that pairs up with our 2. So we're going to take our x over 2 and pair that up with our number over number, in this case 12 times the square root of 3 over 1. Cross multiply, and so we get 2 times 12 times the square root of 3. And so what we do is, since these two numbers are both on the outside, we multiply those to give us the answer 24 times the square root of 3, and there's your x. So it all comes back to similarity in proportions, and we'll do the rest of them when we're together.